Unit 6 is a continuation of factoring, and we will be doing some factoring of trinomials in here, but we're also going to be factoring different types of polynomials. Remember, polynomials are things that have lots of terms. So, for example, 4x plus 7 is a polynomial. Another example is 6x to the fourth plus x cubed plus x minus 2. These are polynomials. The polynomial just means it has many terms. It has more than one piece to it. So, some rules about factoring and some rules about polynomials. Starting with, to factor something means to write it as a product. Product means to multiply of its factors. And the factors of a polynomial are also polynomials. And the last thing is a polynomial that can be factored is called reducible. It's probably also important to write down that a polynomial that cannot be factored is what we call prime. So a polynomial that can't be factored is prime. And if it can be factored, it's reducible. And that's the same true of that's the same as any fraction or any number that's can't be factored is also called prime. So when we're factoring, the first thing we're going to talk about is using the grouping method, which we will a lot of times call greatest common factor. So using the grouping method to factor a polynomial is like using the distributive property backwards. It pulls a common factor out of the product. So thinking back to distributive property, if I have something like this, a parentheses b plus c, well, we know that when we see parentheses, we're supposed to distribute. We're supposed to multiply what's on the outside times what's on the inside, which means I need to multiply a times b, which is ab. And then I need to multiply a times c, which is ac. So I end up with ab plus ac. Well, the opposite of that would be taking something like AB plus AC and looking for what they have in common. Well, in both of these parts, you see the letter A. So I'm going to write down A because that's what they have in common. I'm going to mark it out. And everything they don't have in common goes on the inside, which would be B plus C. So when I factor using the grouping method, AB plus AC, I get A times parentheses B plus C. So again, I'm just backwards distributing. So that's what they did here. In the second example, they gave you one with a polynomial. So they distributed 6x in. So 6x times x is 6x squared. 6x times 2 is 12x. There should be an x there. And just for continuation purposes, there should also be an x in the other problem. That is a typo on the notes, not my fault. So what I'm looking for is and when I'm going backwards, I'm looking for what these two pieces have in common. So I would encourage you when you're doing this, as annoying as it's going to seem, I would encourage you to write all of these pieces as products of its prime factors. So that means I need to take 6 and I'm going to prime factor. Well, 6 is the same thing as 2 times 3. So instead of 6x squared, I'm going to write this as 2 times 3. And then instead of x squared, I'm going to write x times x plus 12. Well, if I prime factor 12, I can do 2 and 6. And 6 is 2 and 3. So I could write 12x as 2 times 2 times 3x. And I'm just looking at my n numbers here. Okay? So again, I'm looking for the greatest common factor. So as I did in this problem, I'm looking for what these two pieces have in common. Well, what shows up in both of them, I see a 2. So I'm going to mark out that 2. I do not mark out both 2's over here because this one there's not 2 2's in the first one. There's just 2 2's in the second one. So I just mark out 1 2 because again, I'm just writing down what they have in common. Okay? They also have a 3 in common. And they both have an x. So I've marked out everything they had in common, and then everything that's left over goes in parentheses. I'm left with x plus 2. I can go ahead and simplify this part on the outside, just the part on the outside, because 2 times 3 is really just 6x. and then in parentheses is still x plus 2. So this is how you do the grouping method, or how you do greatest common factor. Okay, the next section is about factoring quadratic trinomials. So the first thing they tell you to do is to always factor out the greatest common factor. And that's again just looking to see if all of your numbers are divisible by something. So a real quick example, just to kind of help you out, you don't have to write this, would be if I had 4x squared plus 8x plus 4, the very first thing I would do is I'd say, hey, I know that all of these numbers are divisible by 4. And then I would have x squared plus 2x plus 1. And then I would factor at this point. So that's what they're talking about here, is that I need to do this part first. I need to divide by something, or see if I can divide by something at least. All right, number 2, back up here, says if the leading coefficient is negative, so that means that if my x squared part was negative, like negative 3x squared or negative x squared, whatever it was, then I would need to factor out a negative sign. And then my third step is to factor the trinomial. So factoring, remember, is where we go to y equals y1 and y2. The first number times the last number divided by x. And then in y2, we always put the middle number minus x. And that's how we figure out what our factors are going to be. So just as some reminders for vocabulary stuff, any reducible quadratic trinomial can be factored using these rules. And these are just rules that will help us out, or that will be good for your notes. R times S is what's called the trinomial's leading coefficient. P times Q is the constant term C. If C is positive, then our parentheses will have the same sign. So if C was positive, then both of these would either be both positive or both negative. If C is negative, then my parentheses are going to have different signs. So we're in number 4. It says we're supposed to factor each of the trinomials that's listed below. So the very first thing we want to do is we want to see if we can divide all these numbers by something. Well, I have 3, 9, and 6, and I know that I can divide all of those by 3. So I'm going to take care of that first. So when I divide 3 by 3, I get 1x squared. 9 divided by 3 is 3x. 6 divided by 3 is 2. Since I divided by 3, what that means is that when I factor this and get my answer, it's going to have a 3 in front of both of my sets of parentheses. Okay? So, because I factored out that 3 first. So, then I would go to y equals, and in y1, I would do 1 times 3 divided by x. I'm sorry, 1 times 2 divided by x. I apologize. And then in y2, I'm going to do 3 minus x. And what I'm looking for is where the y1 and y2 are the same. And wherever they are the same is where I'm going to find my factors. And what you're going to work out to get is you're going to end up with x plus 1 and x plus 2. So I'm going to write those down. And my final factorization would be 3 times parentheses x plus 1 parentheses x plus 2. For the second one, the first thing I'm noticing is that first term is negative. I don't like that. So it told us to factor out a negative. What that really means is to divide everything by -1. So I'm going to do that, divide everything by -1. So I know that when I have my final answer, it's going to have a -1 in front of my 2 parentheses. So when I divide it by -1, I end up with positive x squared minus 2x minus 15. And then again, we're going to go to y equals, and we're going to type in y1. We're going to have 1 times negative 15 divided by x. And then in y2, we're going to have negative 2 minus x. And we're looking in the table where y1 and y2 are the same. And our factors are actually going to be this time x minus 5 and x plus 3. That's how we'll get, that's what our factors will be. So my final answer will be negative 1 times x minus 5 and x plus 3. All right, so last one. I have 6x squared plus 13x plus 5. I cannot divide all of those by anything. It did not have a negative 1 in front. So I'm just going to go to y equals. In y1, I'm going to put 6 times 5 divided by x. In y2, I'm going to put 13 minus x. And then I'm going to go to my table and look for where they are the same, where y1 and y2 are the same. And I'm going to find that at 10 and 3. Now, don't forget, when you find those numbers, so 10 and 3 are my two numbers, you have to, every single time, divide them by that leading coefficient, in this case 6. And I'm going to reduce it. 10 over 6, I can divide both those by 2. I get 5 over 3. 3 over 6, I can divide both those by 3. And I get 1 over 2. That means that my two factors are 2x plus 1 and 3x plus 5. All right, difference of squares. These are the really easy ones, okay? There's a really simple trick to these, but difference of squares only works if it is subtracted and it has one perfect square subtracted from another perfect square. So like this is a perfect square, and this is a perfect square, and there's a minus sign. Notice there's only 2 terms. That's your first clue. This is a difference of perfect squares. There's 2 terms. Then the next thing is there's a minus sign. And the next thing is that both parts are perfect squares. So when you factor a difference of perfect squares, it's really easy. It's simply, if it's a squared minus b squared, then my perfect squares, my factors of perfect squares becomes a minus b and a plus b. So they have this example over here, 4x squared minus 16. And they're telling you right here that 4x squared is a perfect square because it's 2x times 2x. And 16 is a perfect square because it's 4 times 4. So when I factor that, then it's going to be 2x minus 4 and 2x plus 4. Remember, this only works if it meets all of this criteria over here. It's the only time it works. The last thing we're going to review is the quadratic formula. This is one of the last things you learned about in Unit 4. And this formula works to find any solutions, okay? It can be used to solve any quadratic equation. So to find solutions. And something else I want you to remember. Solutions are really just the point where the graph crosses the x-axis. Both of these are considered solutions. Okay, so keep that in mind. The quadratic formula can always be used. It says x equals negative b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. And recall that a is the number in front of x squared, b is the number in front of x, and c is the number by itself. So all you have to do is plug in the numbers, and we always put them in parentheses. So we have negative b, which is 21, plus or minus, that means that one time you're going to add, one time you're going to subtract, the square root of b squared, or 21 squared, minus 4 times a, which is 3, times c, which is 36, all over 2 times a. Sorry, that should not say negative 3. Let me erase and rewrite that. I did it again. There we go. And then you can put that in the calculator. Don't forget, you can always do alpha y equals and 1, and that will give you the little fraction bar like this, which would be really helpful to you. Okay. A few other last minute things is that a complex number, we talked about those briefly in Unit 4. A complex number is a number that can be written in the form of a plus bi, where a is a real number and bi is an imaginary number. And that's what the I in math that's italicized stands for, is imaginary numbers. So we will not do a whole lot with those. We'll work with them a little bit in Unit 10 of Semester 2 of Algebra 2. And it's probably good to know that the way we get imaginary numbers is we get imaginary numbers when you try to take the square root of a negative number, because the square root of negative numbers do not exist. So, last thing is recalling our discriminant. The discriminant equals b squared minus 4ac. It's part of what's underneath, or it's part of the quadratic formula. It's the part that's underneath there. And if we plug in b squared minus 4ac, we plug in what our numbers are, a, b, and c, into that formula, and we get something that's positive. That tells us our graph has two real solutions and it intersects the x-axis at 2 points. In other words, our graph looks like this. If we plug our numbers in the discriminant and we get 0, that means we have one real solution, and it means it touches the x-axis at exactly 1 point only. So it's going to look like that, where it just comes down, touches it, and goes right back up. And the last one is that if we get a negative number when we plug everything in the discriminant, then what that means is that there's 0 real roots or real solutions, but there's 2 complex solutions or 2 imaginary solutions, and that graph is going to look like that, where it never crosses the x-axis. So looking at your example problems, we're going to do 1 and 2 together. I'm going to refresh on how to do 5, and then we're going to talk about how to find the roots of the polynomial function. So number 1, we're supposed to express the polynomial as a product of its factors. Okay, so we want to check for a couple things. We want to check to see, is this a trinomial? Okay, we've been factoring trinomials. Trinomial means it has 3. That's what tri means in math. So this first one doesn't have 3, so it's not a trinomial. Okay. Second of all, we want to check to see if it's a quadratic. Quadratic means it's got to have x squared and be 3 terms. I'm going to write that in parentheses below it, x squared and 3 parts. Okay, it doesn't have that. Third thing we want to look for is the difference of perfect squares. Let's see if it's the difference of 2 squares. That would mean that 4 and 20 were both perfect squares, and that is not the case. 20 is not. So if it doesn't fit any of those, then the fourth option is to just do greatest common factor. And that's what we're going to have to do on this one. So that means we're going to list out each of these numbers as a product of its factors. So think about the number 4. If I were to prime factor it, I would get 2 and 2. So 2 times 2x. And then 20. If I prime factor 20, well, 20 is 2 times 10. 10 is 2 times 5. So 20 is really 2 times 2 times 5, and then I have 2 x's with that. So I'm looking for what they have in common, what they share. Well, they both have a 2. All of this So I have to put something in its place. I'm going to put a 1. Then I'm left with a plus sign. Then I'm left with a 5 and then another x. So that would be my factorization. I'm going to go ahead and simplify this beginning part over here because I can multiply 2 times 2 and it'll give me 4. So it becomes 4x times 1 plus 5x. If I want to check my math, I could go ahead and distribute that back in and see if I really did get 4x plus 20x squared, but I promise you will. All right, so let's look at the next one. So we're looking for it to be a trinomial. Does it have 3 terms? Okay, it does. Then we're looking to see if it's a quadratic, which means it's got x squared and 3 parts. Maybe, because it doesn't have x, well, it does have x squared or y squared, but it has 3 parts. I don't know. We'll hold off on that one. Is it the difference of 2 squares? No, it's not, because that would mean it would have to be 2 parts and there'd have to be a minus sign, and it's not. It's 3 parts. And the last option is greatest common factor. So let's start with greatest common factor because, yes, it does have 3 pieces, and those pieces do have an x squared and 3 parts, but it doesn't start with x squared. It starts with x cubed or y cubed. So I need to first figure out what they have in common before I do anything else. So I've got to do prime factorization. So I'm going to take 12, and I'm going to figure out what 12 is. Well, 12 is 2 times 6. 6 is 2 times 3. So I could write 12 as 2 times 2 times 3, and then 3y's. Plus 30. Well, 30, I could do 5 and 6 is 2 and 3. So I can write 30 is 5 times 2 times 3, and then I have 2y's. And then I have 9. Let me go ahead and write the sign down, minus. And then 9, well, if I factored 9, it'd just be 3 and 3. So 3 times 3, and then y. So what I'm looking for is what all 3 of these pieces have in common. Okay, well, what shows up in all of them, I see a 3 in everything, so I'm going to mark out that 3. I also see a y in everything, so I'm going to mark out a y. I don't see anything else they have in common, so I'm going to go ahead and just write this. 2 times 2 is 4, y squared, plus 10y minus 3. And that would be my factorization. I actually cannot do anything else with it, so that is my final answer. Okay. All right, 3. This one's going to be a trinomial, a quadratic, where you're going to do y1 and y2. 4 is the same thing. 6 is the same thing. 5 is a little bit different. 5, we don't have 3 parts. So we need to see if it's a difference of perfect squares. Well, I notice it has a minus sign, so that's good. I also can tell that x squared is obviously a perfect square because it's x times x. And 36, I know in my head is 6 times 6. So that means that this is really, I can write this as x minus 6 and x plus 6. The reason I knew that is because there was the minus sign, because x squared was x times x, and because 36 is the same thing as 6 times 6. So I can just take 1x and put it in each parentheses, and I can take 1/6 and put it in each parentheses, and then do a plus and a minus sign. That's how I get my answer. Okay, question 7 and 8 ask you to find all the roots of the polynomial. What I would do is I would use Desmos, DESMOS.com. It's a graphing calculator, because remember, your roots are where the graph crosses the x-axis. That's all it is. So I would go to Desmos, I would graph this function. F of x, remember, is the same thing as y equals. So I have x squared plus 2x minus 24. When you graph this, your graph is going to look something like this. Now, it's not perfect. I'm not the world's best artist. I don't pretend to be. But it's going to look something like this. And your roots are where the graph crosses the x-axis, here and here, which is going to be at -6 and +4. Same thing with 8. I would go to the graph in Desmos. I would not use the graphing calculator on your, I would not use the graph on your graphing calculator. It's not terrible, but Desmos is much better. Our last two examples, 9 and 10, are the same thing. Again, just using Desmos. Desmos, 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 Desmos. It is truly the best graphing calculator app. So Desmos.com.